everyone, today we will talk about a very important topic of your inorganic chemistry, class 12 inorganic chemistry. The name of the topic is the isomerisms in the coordination compounds. Now see, coordination compounds, as you know, that is very useful and it has a huge biological as well as chemical applications. And isomerism is such a thing which you will read in organic chemistry also and inorganic chemistry also there. But दोनों का एस्पेक्ट डिफरेंट है बट द मेजर डेफिनेशन ऑफ द आइसोमरिज्म रिमेन सेम that will be the same molecular formula but different structures, different geometries or different spatial arrangements, right? So today we will talk about a specific part of the coordination isomerisms of the coordination compound, that is the stereoisomerism. Structural isomerism we will talk about in a separate video, but today the most important thing, that is the stereoisomerism, we will talk about. Now stereoisomerism means nothing but the representation of some molecule in the space, right? That means the molecule is not changing its structure. It is basically changing its arrangement. हम ऐसे सोच सकते हैं कि suppose the dress you are wearing at school, the school uniform, definitely you will not wear that school uniform in, let's say, some marriage ceremony or let's say your friend's birthday, right? So there will be some party dress or like that, correct? So but as a person, when you change the dress from school uniform to the party uniform, you basically don't change. You to remain as a person, right? So that is basically stereoisomerisms are those isomers, technically their representation in space changes due to different arrangements, okay? That we will talk about. First part is basically the geometrical isomers, and it is basically the same as what we read in the organic chemistry, that in geometrical isomers you get two type of isomers. That is one cis, that is when the major high priority groups are in the same side. Like हम ऐसे सोच सकते हैं, it will be like this. So this is your cis alkene, and another one is molecule is basically called the trans, where the major high priority groups are in a two different directions, right? So cis and trans. These optical isomerisms are also one of the part of this organic chemistry also. The same concept. The thing is that the molecule, the light will pass through the molecule, and if the polarized light changes the pathway, the molecule is known as the optically active. Perfect. Now, when I say optically active, it will either go towards plus sign and either go towards minus sign. अब ये सब details में जानने के लिए you have to see our video on optical isomerisms. Okay. So basically, this will give you two type of isomers. One is called the D or the plus, that is called the dextrorotatory, and another one we call L or the minus, or is called the levorotatory. So D stands for dextro, D stands for dextro, and L stands for levorotatory. Fine. Now see, when we talk about the coordination complexes, the complexes usually are ML2, ML4 and ML6, right? So when we say ML4 and ML6, हमारे दिमाग में पहले सबसे पहले जो चीज आता है, that is a tetrahedral complex. Tetrahedral complex, that is ML4 geometry. Another one is a square planar complex. This is also an ML4 geometry, and we will get ML6 geometry, that is your octahedral complex, right? So here I am writing ML4 complexes and here I am writing ML6 complexes. Now both of them will show different stereoisomers, right? Or we will talk about that in the video. This video we will talk about the geometries and the optical isomers if it is there for the ML4 complexes, and the next video we will talk about the same thing about the ML6 complexes. So let's see what happens to the ML4 complexes. Now see, if we draw a general structure of a ML4 complexes, this either has to be your tetrahedral molecule or it either has to be a square planar molecule, right? So if I see the tetrahedral molecule, so it will look like this. It will look like this, and if you see very clearly, very specifically here, this particular molecule will not show any kind of geometrical isomers, right? But if these all four ligands are different all 4 ligands are different, then this metal center is called a chiral metal center. This metal center is called chiral metal center. Chiral metal center, right? And since this chiral metal center, that means this will show your DL isomer. That means the molecule will be optically active. So it will not show any kind of optical isomers, geometrical isomers. Now see, but if I talk about ML4 square planar complexes, ML4 square planar complexes, तब क्या देखेंगे हम यहाँ पे? We will see very carefully in the ML4 geometry, it is basically a plane. It is basically a plane, right? So it's basically a plane where, let's say, these are the 2L front side and these are the 2L back side. So if it is a plane, that means the molecule has a plane of symmetry. Agar molecule में plane of symmetry hai, then definitely the molecule will not show any kind of, optical isomers. The molecule will not show any kind of optical isomers. Correct? So, it's obvious. That means tetrahedral complexes will show optical isomers but will not show geometrical isomers, and the square planar complexes will not show optical isomers but it will only show the geometrical isomers. Now let's see what kind of geometrical isomers the square planar complexes shows. Chalo. Okay. Now see, when I'm saying ML4, that means this ligand has to be different, correct? That means what are the possibilities are there? The maximum different will be MABCD, means where all the ligands are different. All the ligands are different. It can be also MAABC. This is one possibility. Or it is another possibility MAABB. This is one possibility, correct? Or another possibility MA2B2. This is also one possibility. So there are a lot of possibilities are there. And if it is that, let's see. हम बाद में देखेंगे. First, let's talk about this particular molecule, that is your MA2B2. First one, MA2B2. एक example लेते हैं. PT NH3 whole 2 Cl2, this molecule. This molecule is called platinum molecule. Okay, and this molecule exhibit in 2 different forms. पहला form क्या है? पहला form देखते हैं. The first form is your PT NH3 Cl. This is first one. Or if we exchange this one, then what we will get? NH3 Cl NH3. Now see here, the 2 Cls are the same side. So definitely this is called cis and the molecule is called the platinum. Right? And this molecule, the 2 Cls are opposite to each other. Correct? 2 Cls are opposite to each other. So this is called your transplatinum. Got it? Okay. Now, next category. Let's say MA2BC. ये वाला देखते हैं. MA2BC. Now, what happens in MA2BC? MAABC. This can be one possibility. दूसरा, second possibility, MAABC. Now see, this molecule, we will say it is cis. This is cis with respect to A. Cis with respect to A. And this molecule will be called trans with respect to A. Trans with respect to A. That means we have to find the common molecule common ligand that will, with respect to that, we will define that which is cis and which is trans. Okay. Now, if this molecule, let's say, ऐसे होता, means this is a monodentate ligand, right? Now, if let's say this molecule was a bidentate ligand, like this, MAABC, then what is the possibility? Then we would have like this. Now, is it possible to have a trans here? No. This molecule will only give you the cis form. So, there will be no trans. There will be no trans. Got it? Clear, everyone? Okay. Now, the next one. Next category, let's see. If I have like this, MAB, okay, MAB whole 2 means it is a bidentate ligand but having 2 different donor centers. Right? Like we know the molecule glycinate. Glycinate. Okay, what is the structure? Just you draw simple amino acid glycine. CH2, C, O minus and NH2. Right? Now here if you see here very clearly, there is 2 donor centers. Nitrogen is a donor center and the oxygen is a donor center. So there are 2 donor centers. So this makes you the density is equal to 2. Okay. अब दूसरा चीज देखते हैं. Now see, when this molecule, let's say this is your A and this is your B, two centers. So it will be like this, M, A, B, A, B. This is one possibility. Correct? This is one possibility. Another possibility is also there. That is M. That is M, A, B, B. Correct? This is one possibility is also there. Okay. Now see here, if here particularly, with rest, both of the A are in the same side. Both of the A are in the same side. So this is called cis geometry, and both of the A here in the 2 different sides, that is called trans geometry. That is called your trans geometry. Okay. And last one is remaining here that we know is something called M, is something called the last one, that is M, A, B, C, D. That means all 4 categories of the ligands are completely different. Let's see. So one by one. M. First, let's draw in this way. Is a trick to do. A, B, C, D. Okay. Now what I will do? I will keep the A fixed and exchange B and D. That is a possibility, but that will give you the same. But what we'll do? We will fix A and we will change B and C. Now let's see. Fix A and change B and C. This is another isomer. There will be another one also. There will be another one also. Fix A, change A and D. Your fix A and change C and D. Okay. But is it true? Is it okay? But isko wrote karo. Yes, correct. Done. So there will be 3 isomers are there. There will be 3 isomers are there. Okay. So, but these all isomers are not your trans isomer or cis isomer. These are the simple isomers. Okay. Right. So this was all of your ML4 geometries. In the next video, we will talk about the ML6 geometries. And if you like this video, please subscribe and share with your friends. And if you have any questions or any queries regarding this particular topic, then don't hesitate to write in the comment section. So bye everyone. For the ML6, check the next video in the link.